Here we've got a reaction where lithium reacts with HCl, and we can see it produces LiCl, so lithium chloride and H2, right, molecular hydrogen. We've been asked to calculate the mass of lithium chloride produced from the reaction, and we've been told that the amount of lithium that reacts by mass is 38.27 grams, and we've also been told that the HCl is in excess, right? The HCl being in excess tells us that the limiting reagent on the reactant side is the lithium rather than the HCl. And on that basis, we can say, well, what's going to determine the amount of lithium chloride produced is primarily the amount of available lithium, right? Okay, so how am I going to approach this? Well, to work out the mass of lithium chloride produced in this reaction, we need to get an amount of substance, right? And then from the amount of substance, we can work out the mass. But we don't have that yet. What we have is a mass of lithium. But what we can do is we can use this mass of lithium to calculate an amount of substance of lithium, and then use the molar ratios given in the balanced equation here to work out from that the moles of lithium chloride, and then work out the actual mass of it, right? So let's go through that process. Now, the equation we're going to be using here is the fact that the mass is equal to the moles N multiplied by the molar mass MR, right? And so in this case, this would be equal to the number of moles of lithium multiplied by the molar mass of lithium. And what we're actually trying to get is what the moles of lithium is, right? So let's divide both sides of this equation to make the moles a subject. Let's divide both sides by the molar mass, right? And that would cancel here, and it would give us the equation that states that the number of moles N is equal to the mass divided by the molar mass. So in the case of lithium, if we're trying to work this out, what we need now, since we've got the mass, we need to work out the molar mass. So what's the molar mass of lithium? Well, we can work that out from the periodic table based on the relative atomic mass. So as you can see, lithium is here below hydrogen. 6.9 is the relative atomic mass. We can say that the molar mass of lithium, as you can see, is simply it's elemental lithium. Effectively, it's in its metal form. So this would be MR of lithium is equal to 6.9. Okay, so quite straightforward. We don't have to really calculate anything. It's just Li, right? So we use that value now in this equation. So the N, so the moles of lithium, right? So you see, therefore the moles of lithium is equal to so 38.27 divided by 6.9. Okay, and so I invite you to have a go, work that out and see what you get when you've calculated that. So if you had a go to try to calculate that, what you should have found is that you would have gotten 5.546 3768. Okay, and that's in moles, right? So mole. So that's the moles of lithium. Now let's look at the equation carefully. What we're trying to do when we're looking at the equation is we're going to compare the moles of lithium on a ratio basis compared to the moles of what we've been asked to calculate the mass of. So this, in this case, is LiCl. Okay, so we're going to compare the two. Looking at the coefficients in the balanced equation, we can see that lithium actually has a coefficient of 2, and LiCl also has a coefficient of 2. So the actual ratio between them is a 2 to 2 ratio, which if we just reduce that to the the common factors, would be just simply a 1 to 1, right? So all I've done is I've just divided both sides by 2. So it's a 1 to 1 ratio, and on that basis we can say that therefore I mean the ratio basically says the same thing, but I'm going to just write this again just for clarity, is that the moles of lithium is equal to the moles of LiCl, right? This is effectively what this is telling us, and therefore the moles of LiCl is equal to this number we calculated, right? So it's equal to 5.5463768 moles. And we've been asked to calculate the mass of lithium chloride, so which we don't have yet. We need to effectively multiply the moles, right? So in this case, we're trying to work out a mass, as you saw from the equation here, that the mass is equal to the moles multiplied by the molar mass, right? So we effectively say, well, okay, get that being the case, we can say that therefore the mass of LiCl is equal to so what I'm going to do before I go into this, I need to actually work out the molar mass of lithium chloride, right? So I'll use the periodic table. So to work out, which is going to be basically MR of LiCl is equal to 6.9 plus, and obviously we could write there if we wanted to 6.9 times 1, but it's times 1, so I'm not going to write it. 6.9 plus 35.5, right? And yeah, if you work that out, you should get what the molar masses of lithium chloride, that's 42.4 grams per mole. Okay, now at this stage we can now use this molar mass in what we were establishing just now. So take this value, so that's 42.4 multiplied, we literally just multiply it by the above, the moles of yep. And what's that going to give us? Well, if you work that out, what you should find is that you're going to get 245.1663683, and that's going to be in grams. Okay, so that is what we get for M when we work this out. Now if we refer back to the equation, if we refer back to the question, you see that the question makes a very specific, applies a very specific constraint to what the format of our answer. It says give your answer to a maximum of 2 decimal places, right? So it's important to pay attention to. This is obviously not to 2 decimal places, so effectively we'd actually say, okay, that actually is equal to, we need to do some rounding, so we need to say that it's 235.17, right? And that's going to be in grams, and then that's the answer to 2 decimal places. Okay, so this is going to be our mass of lithium chloride.